Somewhere right now, a bolt of lightning is striking the earth. And in that single blinding flash lasting less than 1 second, nature is doing something that a $200 billion industry has spent decades trying to make you believe only they can do. That strike is fixing nitrogen, feeding the soil, sending an invisible electrical pulse deep into the ground that wakes up microbes, charges mineral ions, and triggers a cascade of biological activity that no synthetic fertilizer bag can replicate. And it's completely, absolutely free. Now here's the question nobody in the gardening industry wants you to ask. What if you could capture that energy, not just during a storm, but every single day, with nothing more than a copper rod and $3? That's not a metaphor. That's not clickbait. That is a 278-year-old scientific principle that was practiced by European farmers, documented by an 18th century French physicist, quietly used to grow record harvests across 2 continents, and then buried. Not because it didn't work, but because it worked too well for an industry that needed you dependent on their products. My name doesn't matter. What matters is what you're about to learn. Because by the end of this video, you will never look at a rainstorm the same way again. You will understand why your soil is electrically starved, and you will know exactly how to fix it for the price of a cup of coffee. The sky has been trying to feed your garden this whole time. You just weren't given the antenna. To understand why a $3 copper stake could change everything about the way you garden, you have to go back. Not 10 years, not 50 years, but all the way back to 1746. To a candlelit laboratory in Paris, where a quiet, meticulous physicist named Jean-Antoine Nollet was doing something that would have gotten him laughed out of a modern agrochemical boardroom. He was electrifying seeds. Nollet wasn't a farmer. He was one of the most respected natural philosophers in Europe, a man who had demonstrated electrical experiments before the French royal court. But in 1746, he noticed something that stopped him cold. Seeds placed inside an electrostatic field, exposed to the same kind of invisible charge that builds up before a thunderstorm, germinated faster. Not slightly faster. Measurably, consistently, reproducibly faster. He documented it, he published it, and for a brief moment, the scientific world paid attention. But it was the man who came 37 years later who turned that curiosity into something that would feed nations and then be forgotten on purpose. In 1783, a French Catholic priest and natural scientist named Abbé Pierre Berthelon published a book that should have rewritten the history of agriculture. Its title was De l'électricité des végétaux, on the electricity of vegetables. It was not a pamphlet. It was not a fringe theory. It was a dense, methodical, 500-page scientific treatise documenting hundreds of experiments showing that plants exposed to atmospheric electricity grew larger, faster, and with greater yield than those that were not. Berthelon didn't just theorize. He built what he called an electrovegetometer, a device designed to collect atmospheric electrical charge from the air and route it directly into the soil around crops. He tested it, it worked. And for the next 100 years, farmers across France, England, and parts of Germany quietly adopted variations of his method, passing the knowledge from father to son the way people used to pass down the most valuable things, in secret without writing it down, because the man who grew twice the harvest in a drought year didn't necessarily want his neighbor to know why. By the mid-1800s, scattered agricultural journals across Europe were publishing small but striking reports. A vineyard in Burgundy that had been struggling for a decade began producing exceptional harvests after the owner began driving iron stakes around the perimeter of his rows. A farmer in Devon, England, reported that his root vegetables had nearly doubled in size after installing what he described as earth conductors, copper-tipped wooden posts, at the corners of each bed. These weren't myths. These were observations recorded by literate men in an era when agricultural journals were among the most serious scientific publications available. Then came the 20th century, and with it, something that would erase all of this almost completely. The story of how electroculture disappeared is not a conspiracy in the dramatic sense. It is something quieter and more insidious than that. It is the story of economic momentum. When Fritz Haber and Karl Bosch cracked the process of synthetic nitrogen fixation in 1909, the Haber-Bosch process. They handed the industrial world a lever of almost incomprehensible power. Suddenly, nitrogen, the single most limiting nutrient in most soils, could be manufactured in a factory. Bagged, shipped, sold. The timing was catastrophic for electroculture. World War I consumed the world's attention. World War II destroyed what was left of traditional agricultural knowledge across Europe. And when the wars ended, the chemical industry was ready. It had factories, it had capital, it had government contracts, it had the infrastructure of the Green Revolution behind it. And the Green Revolution had no room for copper stakes and atmospheric electricity, because copper stakes and atmospheric electricity couldn't be patented, scaled, or sold at $80 a bag. By 1950, the electrovegetometer had become a footnote. By 1970, it wasn't even that. The researchers who had been quietly publishing papers on plant electrophysiology found their funding redirected. Their journals folded. Their work was absorbed into obscure archives that nobody indexed and nobody read. A practice that had fed European villages for 150 years was erased from agricultural memory in less than 2 generations. And the $200 billion fertilizer industry that replaced it never once funded a large-scale study 3. Before we talk about copper stakes and what they do to your soil, you need to understand something that most people have never been told, something that atmospheric scientists have known for decades, but that has never once appeared in a mainstream gardening magazine, a fertilizer advertisement, or a government agricultural advisory. The Earth is not electrically neutral. It never has been. And the space between the ground beneath your feet and the sky above your head is, at this very moment, alive with electricity. This is not poetry. This is physics. The phenomenon is called the global atmospheric electric circuit, and it has been measured, studied, and published in peer-reviewed journals since the early 20th century. Here is what it means in plain terms. At any given moment, there are approximately 2,000 thunderstorms active simultaneously across the planet. Those storms act as generators, pumping electrical charge into the upper atmosphere and maintaining a permanent voltage difference between the ionosphere and the Earth's surface. That voltage difference, measured at ground level on a clear day, runs between 100 and 300 volts per meter of vertical height. Standing in an open field right now, your head is at a measurably higher electrical potential than your feet. The field is invisible. You cannot feel it. But it is there, every second of every day, pressing downward through the atmosphere toward the ground. Plants have been living inside this electric field for 450 million years, and the evidence suggests they evolved not merely to tolerate it, but to use it. Research published in the journal Environmental and Experimental Botany has documented that plant root tips carry a measurable negative charge, which creates a natural electrical gradient between the root zone and the soil surrounding it. This gradient drives ion movement, pulling positively charged mineral ions like calcium, potassium, and ammonium toward the root surface through a process that works alongside, and in some conditions independently of, conventional osmotic uptake. In simple terms, the root is not just waiting passively for nutrients to drift toward it. It is, in part, electrically fishing for them. And the stronger the electrical environment around the root, the more efficiently that fishing works. Now here is where the story of modern agriculture becomes genuinely disturbing, because the same industrial practices that replaced electroculture, synthetic fertilizers, heavy tilling, compaction from machinery, the elimination of soil organic matter, have also systematically degraded the electrical conductivity of agricultural soil. Healthy soil, rich in moisture, organic matter, and microbial life, is a reasonably good electrical conductor. It allows charge to move through it, to distribute, to interact with root systems the way nature designed. But compacted, chemically dependent, biologically depleted soil, the kind that covers hundreds of millions of hectares of modern farmland, is effectively an electrical insulator. It blocks the very current that plants spent millions of years learning to harvest. The industry that claimed to be feeding the world has, in the process, electrically disconnected crops from the sky. And then there is what happens during a storm. Every bolt of lightning that strikes the earth is doing something that no fertilizer factory can replicate with the same elegance or efficiency. It is fixing nitrogen. When lightning superheats the air around it to approximately 30,000 Kelvin, 5 times hotter than the surface of the sun, it breaks apart the extraordinarily stable triple bond of atmospheric nitrogen molecules and forces those nitrogen atoms to combine with oxygen, forming nitrogen oxides that dissolve into rainwater and fall as dilute nitric acid directly into the soil. Agronomists estimate that global lightning activity fixes somewhere between 5 and 12 kilograms of nitrogen per hectare per year through this process alone. That number sounds modest until you realize it is happening everywhere, simultaneously for free, with zero energy input, zero factory emissions, and zero cost, and that it has been doing so continuously for 4 billion years. The Haber-Bosch process, by comparison, currently consumes approximately 1 to 2% of the entire world's annual energy supply to produce synthetic nitrogen fertilizer. 1 to 2% of all the energy humanity generates, burned every year, to manufacture something the atmosphere has been providing at no charge since before the first plant grew from the first patch of ancient ground. But here is the detail that the electroculture researchers of the 18th and 19th centuries understood intuitively, and that modern soil electrophysiology is beginning to confirm quantitatively. The nitrogen fixed by lightning is only part of the story. The electrical pulse itself, the charge that moves through the soil after a strike, the atmospheric field that intensifies before and during a storm, the slow, steady pressure of the global electric circuit pressing down through the topsoil every hour of every day, is biologically active in ways that go far beyond simple nutrient delivery. It accelerates enzymatic reactions in microbial communities. It increases the permeability of plant cell membranes, allowing faster uptake of water and dissolved minerals. It stimulates the production of auxins, the growth hormones that govern how fast and in which direction a plant extends itself toward light and water. In short, electricity is not just feeding your plants. It is, at the most fundamental biological level, telling them to grow. And most gardens, on most plots of land, in most cities and suburbs across the world right now, are receiving almost none of it. The concrete, the compaction, the chemical crust on the soil surface, it is all acting as insulation, cutting the root zone off from a 300 volt per meter energy source that has been raining down on this planet since long before the first human ever put a seed in the ground. That is what you have been missing. And that is exactly what a $3 copper stake is designed to give back. Now we move from the atmosphere down into the soil itself, down past the surface, past the topsoil layer, into the dark, dense, electrically complex world where roots actually live and where the real story of electroculture plays out at the cellular level. Because understanding why a copper stake works requires understanding something that most gardening content never bothers to explain: what a plant root is actually doing, moment to moment, at the boundary between living tissue and mineral earth. A root tip is not a passive tube. It is one of the most electrically active structures in the biological world. The outermost cells of a growing root maintain what plant physiologists call a membrane potential, a voltage difference across the cell wall that sits, in healthy conditions, somewhere between -120 and -200 millivolts. That charge differential is not incidental. It is the engine. It is what drives the protein pumps embedded in the cell membrane, structures called ion channels and HAT-phase pumps, that physically pull mineral ions across the boundary from soil water into the root interior. Calcium comes in, potassium comes in, nitrate comes in, phosphate comes in. The whole nutritional intake of the plant, the entire process that fertilizer companies have built a $200 billion industry around trying to optimize, is fundamentally and irreducibly electrochemical. It runs on voltage, it runs on charge. And when the electrical environment around the root is enriched, when there is more charge moving through the soil matrix surrounding those root tips, the pumps work faster, the channels open wider, and the plant feeds more efficiently than any bag of synthetic nutrients alone can achieve. This is not fringe biology. This is standard plant electrophysiology taught in graduate-level botany programs at major universities. What is not taught, what is conspicuously absent from the curriculum of every agricultural college that receives funding from the petrochemical and agrochemical industries, is the practical implication of that knowledge. If root uptake is electrochemical, and if enriching the electrical environment of the soil improves that uptake, then the most fundamental act of gardening is not adding nutrients. It is restoring electrical conductivity. Everything else is secondary. The researchers at the University of Miyazaki in Japan understood this. In a study published in 2008, they constructed a series of controlled growing environments in which lettuce and tomato plants were exposed to weak, continuous electric fields applied through electrodes embedded in the growing medium. The fields used were gentle, in the range of 1 to 3 volts per centimeter, well within the range of what naturally occurs in electroculture installations. The results were not gentle at all. Lettuce biomass increased by an average of 38% compared to control plants grown under identical conditions without the electrical stimulation. Tomato plants showed a 20% increase in fruit yield. Root mass, the underground infrastructure that determines a plant's long-term health and drought resistance, increased in both species by more than 25%. The researchers attributed the gains to accelerated ion transport, increased root surface area development, and enhanced activity of soil microorganisms in the electrically stimulated zone. A separate line of research conducted at Wageningen University in the Netherlands, one of the world's most respected agricultural research institutions, examined the effect of weak electrical fields on mycorrhizal fungi, the underground fungal networks that form symbiotic relationships with plant roots and dramatically extend their effective nutrient-gathering range. The findings were striking. Mycorrhizal colonization rates increased significantly in electrically stimulated soil, suggesting that the copper stake effect is not limited to direct root uptake, but extends to the entire underground ecosystem that supports plant health. The fungi grew faster, colonized more root surface, and transported more phosphorus to their host plants when the soil around them carried even a modest electrical charge gradient. Here is where intellectual honesty requires a pause, because this is the moment in most videos of this type where the claims become absolute, where nuance disappears, and where a legitimate scientific phenomenon gets stretched into something it cannot support. That is not what this channel does. Electroculture is real. The science behind it is real. But it is not magic, and it is not a universal solution. The magnitude of the effect depends heavily on soil type. Sandy soils with low mineral content conduct electricity differently than clay-heavy soils, and the results vary accordingly. Moisture is critical, dry soil is a poor conductor, and a copper stake in drought-stressed powder-dry earth will do very little until water is present to create the ionic pathway that carries charge from the metal into the root zone. The method works best as a complement to good foundational soil health. Adequate organic matter, reasonable moisture retention, active microbial life. If your soil is biologically dead, electroculture will accelerate the activity of organisms that aren't there yet. It is an amplifier, not a substitute. A garden that is already alive will respond dramatically. A garden that is chemically scorched and compacted needs biological rehabilitation first and electrical enrichment second. That said, for the vast majority of home gardens, plots that have reasonable soil, receive regular watering, and support at least a moderate level of organic activity, the copper stake method delivers results that are, by any honest measure, disproportionate to their cost. 38% biomass increase on lettuce, 20% more tomatoes, 25% deeper, stronger root systems, for $3 and 15 minutes of work. Now ask yourself the question that the Miyazaki researchers did not ask in their paper, because academic papers are not permitted to ask it, but that you are absolutely permitted to ask right now. If a $3 copper stake can produce results that rival or complement a season's worth of fertilizer applications, and if this has been known and documented and published in peer-reviewed journals, then why has not a single major agricultural company funded a large-scale field trial to confirm or refute it? Why has not a single government agricultural extension service included electroculture in its recommendations to farmers? Why, in the 278 years since Jean-Antoine Nollet first electrified a seed and watched it grow, has this knowledge never made it into the mainstream? The answer to that question is not in the science. It is in the money. And that is exactly where we are going next. Let's talk about the number 223 billion. That is the current estimated value of the global fertilizer market as of 2024, according to Grandview Research. Not 223 million, not $2 billion, $223 billion generated every single year by selling farmers and gardeners the nutrients that their soil, their atmosphere, and a $3 piece of copper could be providing at a fraction of the cost. That number is not just a market statistic. It is the financial architecture of a system that has every structural reason in the world to ensure that you never hear the word electroculture from a mainstream source, and every reason to make certain that the 278-year-old science behind it stays exactly where it has been since 1950, buried in archives that nobody reads, cited in papers that nobody funds, and practiced by nobody except the small, scattered community of gardeners and farmers who stumbled onto it by accident and refused to let it go. To understand how a piece of knowledge gets erased, you have to understand how science gets funded. Independent research, the kind that asks uncomfortable questions about whether expensive products are actually necessary, does not fund itself. It requires grants, it requires institutional support, it requires the approval of university departments that depend on corporate partnerships to keep their laboratories running. The four largest fertilizer companies in the world, Nutrien, Yar International, CF Industries, and Mosaic, collectively generate over $50 billion in annual revenue. They sponsor research chairs. They fund agricultural colleges. They sit on the advisory boards of the same government bodies that issue planning recommendations to farmers. This is not speculation. This is publicly documented in their annual reports and university partnership disclosures. And the research that gets funded inside that system is, almost without exception, research that asks how to use more fertilizer more efficiently. Not research that asks whether fertilizer could be partially replaced by a copper rod in the electrical field that has been pressing down through the atmosphere since the Precambrian era. This is the moment in this video where you need to make a decision about your own identity. Because there are two kinds of people watching right now. The first kind will hear everything that has been said in the last 20 minutes and think, interesting, but probably fringe, probably exaggerated, probably not worth the effort of $3.15 in the garden. That person has been trained carefully, systematically, over decades of advertising and institutional messaging, to distrust simple solutions, to believe that effectiveness must come with a price tag, and to feel vaguely embarrassed by the idea that a farmer from 18th century France might have known something that a modern agrochemical corporation does not want them to know. The second kind of person watching right now is feeling something different. They are feeling the specific discomfort of recognizing a pattern they have seen before, in other industries, in other contexts, the pattern of a large financial interest quietly shaping what counts as legitimate knowledge and what gets dismissed as folklore. If you are feeling that discomfort right now, good. That feeling is not paranoia. That feeling is pattern recognition. And it is exactly the instinct that the $223 billion fertilizer industry, the $89 billion pesticide industry, and the $45 billion garden products industry, a combined market of over $357 billion built substantially on your dependency, would prefer you to suppress. Here is a fact that does not appear in any fertilizer company's marketing material. The Haber-Bosch process, the industrial backbone of synthetic nitrogen production, currently accounts for approximately 1.4% of global CO2 emissions annually. To put that in perspective, that is more than the entire aviation industry. Every bag of synthetic nitrogen fertilizer that goes into the ground carries an invisible carbon cost that the price tag does not reflect, that the advertising does not mention, and that the agricultural extension services funded by the same industry do not emphasize. Meanwhile, the atmospheric nitrogen fixation happening above your garden right now, the lightning, the electrical gradients, the slow ionic exchange between sky and soil that electroculture attempts to amplify, produces zero emissions, requires zero factory energy, and has been carbon neutral since the first thunderstorm rolled across the first continent 4 billion years ago. The industry did not just bury electroculture because it was cheaper. They buried it because it was free. And free cannot be monetized, patented, scaled into a supply chain, or used to create the kind of dependency that generates $223 billion a year in recurring revenue. A farmer who learns to work with the electrical life of their soil is a farmer who needs less of what they are selling. And a gardener who drives a copper stake into the earth and watches their plants respond is a gardener who has started asking questions that the industry cannot afford to have answered at scale. That gardener is you, starting right now.